15.4 deals with similarity and congruence. Now remember, we've done similar shapes before when we did the videos on enlargement. So if I've got two shapes that are similar, then their corresponding sides will be in the given ratio. So for example, if I'm an enlargement scale factor 2, but I've got a small triangle and a bigger triangle whose sides are 2 times as big as the small one, then that's an enlargement, and therefore the two triangles are similar. Now, whilst the corresponding lengths are in a given ratio, each length is in the same given ratio, the angles will be identical. So in the enlarger shape, the angles stay the same, but the lengths become different, whether it gets bigger if you enlarge it by a positive scale factor, or whether it gets reduced down in size by multiplying by a fractional scale factor. So, but when we talk about congruent shapes, like here we've got an example of question 3, we're looking for shapes of identical shape and size. The angles will be identical and the lengths are also identical. So I can flip congruent shapes upside down, rotate them, do anything I want to them, but everything stays the same. So if I look at triangle A, for example, this has got an area of 6 centimeters. I think this is centimeter square paper anyway, just scaling it up a little bit. That doesn't make it congruent to C. But look, if these are all rectangles, and 1, 2, 3, 4, 5, 6 is a 2 by 3, and the C is also a 3 by 2 or 2 by 3. It's been flipped round the other way. So I'm going to match A and C together. They're identical shape and size. All the corresponding lengths are the same, and all the angles are the same. Now, let's go for a different colour. If we look at trapezium F, so basically I've got 1, 2, 3, 4, 5, 6 squares there, so 3 by 2, and plus this 2 by 1 triangle. So I'm looking for something that is congruent to F, and I is exactly the same. Look, 1, 2, 3, 4, 5, 6, 2 by 3 rectangle, and a 2 by 1 triangle. So I and F are congruent. What else? Oh, I think I'm going to do B as well. Look, 3 by 2 triangle, 3 by 2 rectangle, and a 2 by 1 triangle. So F, I and B are congruent. That's that. What about these two trapezia here? Just like F and B, but it's smaller. It's a 2 by 2 square, and the triangular part is a 1 by 2. Same with E, 2 by 2 square and a 1 by 2 triangle. So let's make these the same as well. So G is congruent to E. Now H I can't tell honestly because it's drawn on its side. Now it's very hard to tell because the vertices don't finish comfortably where the grid lines cross. So I'm going to go, I think they're trying to be the same. I don't think they're trying to be difficult. And obviously in class, if you measure this rectangle H, measure the lengths and the widths with your ruler, then you can see more clearly than I can. But I'm going to go for them being the same as A and C. So H, I reckon, is congruent to A and C. Now D stands alone, I'm sure, for the simple reason that it's huge and there's nothing quite like it anywhere on the page. So that's congruent shapes, identical shape and size, all the corresponding lengths are identical in length, and all the corresponding angles are identical too. Alright, essentially, whenever you see the word congruent, think of the word identical in every way. Alright, identical too. Right, question 4 deals with similarity. So it says, which of the following shapes are similar to the red triangle? Now please remember, all these are triangles. Oh, they're all similar because they're all triangles. No, no, no. This is mathematical similarity. Corresponding lengths are in the same ratio, and all the angles, corresponding angles, are the same, identical. So let's look at this red triangle here. We've got a height of 2 and a base of 4 units. So really I'm looking for a ratio of 2 to 4, in other words 1 to 2. So that's, if you like, the rule I'm working with. Every triangle that's got that has a ratio of 1 to 2 in terms of its height to its base will be similar to this red one here, mathematically similar. Now, How about this one? That goes 2 to 5. No good. Let's just cross that one out. No. This one is 1 to 2. Ah, that fits the 2 to 4. Look, 1 to 2. Therefore, let's put a ring around D. What about A? That's 3 up, 4 along. No, that can't be simplified to 1 to 2. So I'm now going to put a red cross through that one. Oh dear. What I mean is I'm going to put a blue cross through that one, so I don't worry about it. So that's gone bye-byes. No good. What about B then? It's working across the page there. I've gone 1, 2, 3 up, 1, 2, 3, 4, 5, 6 across. Let's just try this ratio out, shall we? I've gone 3 to 6. Yes, that's a 1 to 2 ratio. Therefore, that is similar to A. So I'm going to give that a nice little yellow ring there. Yep. Let's put a yellow in the red here. So that's that. So all the little yellow rings means they're similar. Look at D. Look at K. Exactly the same. 1 up, 2 across. 1 to 2 ratio. So K's in. What about this E thing? 1 up, 3 across. That's a 1 to 3. No, that's out of order. So you're not involved in the family. Go back to yellow. What about this F? Well, it's 2 up, 1 across. But hey, so what if it's flipped down on the page? Doesn't matter. If I flip this round the other way, something like this, 1 up and 2 across, look, it's exactly the same. So that F and this little representation spinning it round is exactly the same. So actually F is also similar to the red triangle. G is a waste of time because it's a 1 by 1, so that's going to go. H is a waste of time, it's a 2 by 2, which simplifies to a 1 by 1. That's no good. I, 1 up, 3 across, that's a 1 to 3 ratio. That's no good. Now what about this monster? Look at J. 1, 2, 3, 4 up. 1, 2, 3, 4, 5, 6, 7, 8 across. So I'm playing with a 4 to 8, and straight away you can see that's a 1 to 2 ratio, which fits with the 2 to 4, which is what the red is. So therefore J is similar to the red triangle. So these are my answers then. I can't write them in yellow because you probably can't see them. So which is similar? I've got D, F, B, K and J. All mathematically similar to the red triangle. And I'll stop there, so you can review the difference between congruence and similarity, and at this level that's about as far as it goes. Alright, and I'm now going to look at a few questions in the assess.